substitution. So we're going to start with one that was very much like that first problem on the number string. Y equals 6 and 2x plus y equals 12. Well, kind of like that first problem on the number string, what do you already know? Y. We already know that y is 6. So we're going to take that value of y and we're going to substitute it into the second equation. Where would I put 6 in my second equation? Y. For y, right? You're substituting what you know for where it lies in the other equation. So it would be 2x plus 6 equals 12. Do I then have enough information to find x?
Yeah.
Yeah, what do I need to do? Subtract 6. So 2x equals 6. So divide by 2, x is 3. So kind of filling in the right-hand side here, we knew that y was 6, so where we saw y in the second equation, we replaced it with 6. And since we know that y is 6, my solution, because my solution is a whole set, x and y, right? It's 3, 6. Because how did we solve this last week, at the end of last week? We graphed it. So if I really wanted to, I know that I've started with y equals 6, which is a horizontal line, right? And then if I solve this for y equals, if I'm solving this one for y, negative 2x plus 12. So it would have crossed right here at 3, 6. Okay? So it's just another way to solve the same kind of problem. We just are doing it without using a graph. Which means I could probably use my calculator and my graph to check to make sure my answer is right. Right? At least in the right vicinity. Because sometimes our table doesn't help us on our calculator. But we can at least check that it's in the right area. Okay. Let's look at the second one. A little bit more work involved, but enough information. So this time we need to solve the equation for one of the variables. It doesn't matter which variable, x or y. So the first one, what was already solved? Y equals 6, right? So I need something that says either x equals or y equals. And it doesn't matter which one you choose to solve. So do y'all want to solve the first equation or the second equation? The first. Okay, great. So we can do x or y. Everybody cool with x? How do I take x plus y equals 5 and solve it for x? Not minus x, I'm solving for minus y. So now have I isolated x? Okay. So now I'm done with my first equation for right now. I've used it to isolate a variable. I need to go to my second equation. Y minus x equals 3. So I know from my first equation that x equals what?
5 minus y.
5 minus y. Everybody see that? X equals 5 minus y. So if x equals 5 minus y, Arnav, go ahead and finish that statement.
You put it in parentheses and put 5 minus y and plug it in as x.
Okay, so I'm going to substitute the 5 minus y in where I see x in my other equation. So instead of x, it is now 5 minus y, but nothing else in that equation changes, including that subtraction, because that's going to change a lot of things. Because what do I do with that subtraction? Distribute it. So y minus 5 plus y equals 3. Okay, take a second on your own and solve for y for me. Don't shout it out. Just take a second on your own to solve for y. Okay, what's y? Y equals 4. So I want to write my solution as an ordered pair, but all I have is y, right? So my solution is going to be something 4. How would I get that x value? Go back and plug it into one of your equations. So if I have, let's take the first one, x plus, what is y? 4 equals 5. What's x? 1. There you go. Okay. I'm going to flip over. I'm going a little out of order here. I'm going to flip over, and I want you guys, it's almost the exact same as the first one that we did together. I want you to do number 1 on your own for me. Number 1. So in your case, you already knew x equals -2. What was y? Did anybody leave it as a fraction? Good. -2, -26 over 3. If you put it as a decimal, that's fine. But just thirds are not friendly. Okay. So now, let's look at number 3 together. Is anything already isolated? X. Good. X is isolated. So for right now, we're pretty much done with that second equation. We're using our first to solve. Which variable am I pulling out to plug something else in? X. I'm going to replace x with 3y. So when I rewrite it, 2y plus 3y equals -15. What happens when I combine like terms? 5y equals -15. So y is -3. So I've got half of my solution. I need the other half. Plug it in what? Does it matter if I plug it into the first equation? No. Okay, but it'll be easier for me to plug it back into the second because there's less steps, right? So if I plug this back in, x equals 3 times -3, which is -9. Good. Okay, let's look at number 6. Number 6 together. Actually, no. Let's do number 5 together. Okay, let's look at number 5 together. Is anything already isolated? No, I gotta do some work. What's the only variable there that you see that might not be the easiest one to isolate? 3y. It's going to be a lot of work for me to isolate that y in the second equation. So I'm going to stick with either something in the first or the y or the x of the second. What do y'all think? Something in the first? Okay. Which one? X. Would it be wrong if I said y? No. Okay, so if we isolate x, so x plus y equals 3, what would I move? Y. Okay, so x equals 3 minus y. Where am I going to plug that in? X. So now x is 3 minus y. Is anything going to distribute into that? No, so I could put parentheses, but do I really need them? No. So 3y plus 3y equals 3 minus y. Ooh, hard for me to even see my own handwriting. Okay, So combine your like terms. 2y plus 3 equals 11. So subtract 3. 2y equals what? So y is? You're halfway there. Plug it in. So, y is 4. Easiest to go back into the first one. X plus 4 equals 3. Very good. -1. We did it. We did it. Okay, we're going to bounce back to the front for our last one together. Looking at the second equation, I want you guys to start that process, but as you're going through and you're trying to solve, there's something that starts to happen, all right? So what ends up happening as you get towards the end? So go ahead and substitute in, and when you, okay, which variable did y'all isolate first of all? Y. There's one that's already 1, right? Coefficient of 1. Doesn't mean you're wrong if you isolate it for x, but it's going to be kind of a nasty function if you do that. If you've got a variable that has a coefficient of 1, that is going to be the easiest one to isolate. So y equals -2x plus 4, or 4 minus 2x. Does everybody get that? Yeah. Okay, then you plugged it in. What ended up happening? X became 0. What else? Well, it zeroed out. It canceled out, right? 8 equals 8. So you had 4x plus 2 times -2x plus 4 equals 8. So if you didn't distribute right, that's a problem. Because when I distribute the 2, -4x plus 8. And at that point, you realize you were in for something tricky, right? This cancels, 8 equals 8. Well, what happens if 8 equals 8 on any normal equation? Infinite solutions. Same thing. Infinite solutions. Because here's what's interesting about this. If you graph the first one, you solved it for y, right? -2x plus 4. That line looks like this. If I solve the second equation for y, -4x minus 4x, what do I get when I divide everything by 2? -2x plus 4. What? It's the same line. Coinciding lines, they never leave each other. Everything's a solution, right? What if it was not a true statement? If it said like 8 equals 4? No solution, because that would mean that the intercepts were, or the slopes were the same, but the intercepts were different. Okay? All right. Your task on the back: 2, 4, and 6. We're going to check them, but if you finish before everybody else is done and we haven't checked yet, you may start looking at your homework. And I'm going to be nice today because you have a spiral review due tomorrow and a test review due on Wednesday. You only have to pick 5 total, like total. 5 problems to do on your homework. You need to practice, but I don't need you to practice 20 of them. Okay? Pick 5. All right, so we'll check this in a couple minutes. Number 2, on the practice, on the back. What'd you get? No solution, Phil. No solution. If you go to check and you plug both of those equations into your graph, you would see parallel lines. Parallel lines never cross, therefore, you have no solution. Okay, number 4, what was it? 1, 2. And number 6. 2, 3. Very good.